Hello, welcome to Beauty and Simulations. My name is Lakshman Anumolu. I am excited to share my experience with rendering simulation results photorealistically, and I would encourage all researchers and engineers to do the same at least for some of the final results while presenting at a conference or in a journal publication. In this tutorial, I will present the workflow that I have been following to render results from CFD simulations by considering some examples. Before we start with the introduction, here are few contact details that you can use to send me feedback or ask queries. Please feel free to reach out to me at this email. If you prefer using Twitter, here is my Twitter handle, and of course, you are welcome to provide comments directly on YouTube. There is also a GitHub repository where I host some scene files that we will be using while working with examples. This tutorial is aimed for researchers and engineers who are in the field of computational simulations like CFD, in which the basic workflow includes designing a numerical algorithm, followed by applying that on a given physical or canonical problem, and solving it computationally using thousands of processors to obtain desired output. Finally, we analyze the data and present results. Please bear with me for the next couple of slides where I will quickly present few points related to CFD that most of us are aware of, and I am doing this only for the sake of completeness. In CFD, we solve for fluid flow problems by performing computational simulations using famous conservation laws. And yes, this branch of fluid dynamics cannot be introduced without mentioning Navier-Stokes equation that is used to predict flow properties. Here you go. Basic procedure for a CFD analysis include pre-processing stage followed by solving a problem computationally, finally post-processing obtained results where current tutorial fits in. There are a number of great tools we CFD engineers use to analyze data visually that is obtained from a simulation. Some of them are listed here. Let's take an example where we simulate pouring water into a glass. Video on the left shows an ice surface near water and air interface visualized using TechPlot. While presenting final results of our research, that is, after finishing our usual step of analyzing results and presenting validations, I strongly believe it would add as an additional layer to attract attention of our audience when we present realistically rendered results like the video on right. The workflow we will follow in this tutorial include following steps. First, a CFD simulation is carried out, from which we get surface files in a certain format, for example OBJ. Using these files along with other settings like camera position and lighting, we can prepare a scene. Once a scene is set, we can render that using applications like Mitsuba. Note that there is no need for you to install rendering software. I have prepared Docker and Singularity images for you to use while going through this tutorial or in your work. For this tutorial, you will need to install few utilities. Essential ones are installation of either Docker or Singularity on your system. We will go through this procedure of setting up the environment in the next video. At this point, some of you may be asking, Lakshman, why do we need to install these applications? What are they? I am here just to see how to render CFD results. While these may be new to some, containerization has gained popularity since the beginning of last decade. Don't worry if you have never heard about these. I will quickly introduce them in the later videos and explain exactly how to use Docker images that I prepared. Before closing this video, I would like to note that this tutorial is not aimed for those who are inclined towards computer graphics expertise. There are many excellent tutorials for that. For example, Blender Gurus or CG Masters YouTube channels to learn Blender, and of course Pixar's website for RenderMan. The primary goal here is to encourage all CFD or other simulation researchers whose background is not related to computer graphics to render the results and present your hard work photorealistically. The motivation behind this tutorial started as a post on Reddit, which is presented in the description section of this video. Thank you for watching. See you in the next video.